In this triangle, we have a 90-degree angle and two 45-degree angles. It is fondly referred to as a 45, 45, 90, and it is a special triangle. It has certain attributes. Every single 45, 45, 90 has certain attributes. Well, we learned about this kind of triangle last semester, but we didn't do specifically the 45, 45, 90. So we know that it has two equal angles, which are here and here, right? Those are equal. What else do we know based on what we learned last year? If those two angles are equal, the sides opposite them are also congruent. They're the same measurement, okay? Got it? And the ratios of a 45, 45, 90 are always x, x, and square root of 2x. Now that's not going to make much sense to you, but I'm going to put a 1x, and square root of 2. Okay? So on a 45, 45, 90, I only need to know one thing. I need to know one of the three sides, and I can tell you the rest of the sides if I know it's a 45, 45, 90. And I'll show you how. Let's say this here, and I'm going to give you an easy one first and then a hard one. I'm going to show you why my way works for easy ones or hard ones. But if you can do the easy ones without my way, you can do that. You can just jump to conclusions. So let's say this here is a 5. If that bottom side's a 5, what else do I know? The left side is a 5. And that's 1x and 1x. What would the right side be if x is 5? 5's root 2. You just gunk a root 2 to the 5. Okay, that's a 45, 45, 90. If they give you the dimensions of the bottoms or the left, you just gunk a root 2 on it, and sometimes you have to clean it up a little bit. Let's do a little harder one. Same thing, 45, 45, 90. And now this is 5 root 3. Do know this for sure. This side here is 5 root 3. You hear what I'm saying? 5 root 3. That's how you say that. When you get into pre-cal and trig and functions and modeling, the decimals go away for the most part. There's some parts that still have decimals, but you leave things in radical form, and this is in radical form. And you learned a little bit about it last year, where you were taking things out of the radical and leaving, whatever's left in the radical. Okay, so what do I do to find the last side? I have to multiply that by what? What is that? What was I multiplying it by up here?
So would it be 5?
5 root 3 times what? Not 2.
Root 2.
Very good. Which is 5 root 6.
Wait. Oh, okay.
So we know x is equal to y because in a 45, 45, 90, the two legs are equal. So once you find one, you don't have to worry about finding the other one because it's the same. In a 30, 60, 90, they're not the same. So this one's a little harder because there's not a root 2 gunked onto the 12, right? So you just can't say the two sides are 12. If it was 12 root 2, then the other two sides would be 12, and that would be easy. But when you went from the sides to the hypotenuse, you multiplied by root 2. What do you do when you go from the hypotenuse to the sides? What's the opposite of multiplication? Division. So really, x would be equal to 12 divided by root 2, right? But you can't have a radical in the basement. Do you understand that? How do you get the radical out of the basement? What do you multiply? You multiply it by root 2 over root 2. Pay attention. If you want to get a radical 2 out of the basement, you multiply by root 2 over root 2. Got it? Now, why do you do that? What is square root of 2 over square root of 2? 1. And we're just multiplying that by 1, so we're not changing the value, we're changing the look. okay?
So it's-
You're the same person tomorrow when you come in with different clothes, right? We just changed your look, but you're still the same person. Well, that number is the same number. We're multiplying it by 1, an ugly one, root 2 over root 2. Look what happens. On the top, it's 12 root 2. On the bottom, it's 2, because root 2 times root 2 is 2. Did we get rid of the radical in the basement?
Yes.
And now we can go ahead and simplify 12 over 2 to 6, and that is 6 root 2. So both of these sides are 6 root 2. Now, I know that the ratio of every single 45, 45, 90 is 1, 1, root 2. It's that number, and that number. That's, I know. Ms. Medlin told me, I believe her, I know that. Okay? So I'm going to set up a proportion. And I'm going to put the sides that they gave me opposite. I'm going to put here 45, 45, 90. That's the name of the triangle. You do not use those numbers, though. That's the name of the triangle. Okay? What side is opposite this 45-degree angle? The one with the arrow on it. What?
Oh, that's
X. What side is opposite this 45-degree angle?
Y.
And what side is opposite the hypotenuse? 12. Do I have a full fraction?
Yes.
Then I can cross multiply and get the answer.
I guess you could.
So, well, with both of them, you could do this first, and then you could do the X. It's going to be the same answer. You only have to do one. So this is going to be y root 2 equals 12. Everybody see what I did? Cross multiplication. Divide by root 2. And remember, you don't like put your elbows on the table, you don't eat with your mouth open, and you don't have a radical in the basement. Don't know why that's a rule, but it is. So we need to multiply that by root 2 over root 2 to get rid of the radical. And I get 12 root 2 over 2, which is 6 root 2. So if that 30, the thing opposite the 30 is 4, I'm going to put the 4 under the 1. Who is under the 60 and the root 3?
Y.
Y, very good. That's the side opposite the 60. And the Z is opposite the 90. Yeah? Well, I'm going to find Y first. I've got this complete fraction, the 1/4, and I cross multiply, and I get 1 Y equals 4 root 3. So you're done. Y is 4 root 3. What is wrong with this? Got it? Now I'm going to use the same fraction with the z. 1 over 4 equals 2 over z. When I cross multiply, I get 8 equals z. So z is 8. And I have just solved my triangle. Okay? Now let's look at it the easy way. They gave me the 30. That's 1. The 60, we're going to multiply that by root 3. And the 90, we're going to multiply the 30 by 2. And that's what we did. What is 4 times root 3? 4 root 3. What is 2 times 4? 8.